There's actually, if you'll think back to geometry, there's a formula that we learned in geometry for finding the area of a triangle. Area is equal to half times base times height from geometry. But you've actually got two more formulas that you can use to find the area of a triangle, all based on what you're given. If you're ever given a triangle and you can find the lengths of two legs and the angle between them, that's very important. This theta here in this formula has to be the angle between the two legs. So you've got leg, leg, and then this angle. You can just simply plug it into this formula. The area of this triangle will be 1/2 times leg 1, leg 2, multiplied times the sine of the angle between them. That's another way of finding the area of a triangle. A third way, and this is actually called Heron's formula. Heron's formula says this, that if you've got the three side lengths of a triangle, you can find the area by doing the square root of S, and we need to know what S means. S is half, it's called the semi-perimeter. Half the perimeter. So add A, B, and C and take half of it, and that's what S is equal to. And then plug that into your formula, the square root of S times S minus A times S minus B times S minus C. And I'm going to work you a problem for each of these just to show you how the formulas work. First problem, if I ask you to find the area of this, you've got a triangle with a 30-degree angle and leg lengths of 6 and 7. Now, go ahead and warn you before we start these. On some of these, you won't have leg, leg, and the angle. This is like a side angle side if you want to think back to geometry. Sometimes you won't have side angle sides. You might have this angle down here and this side and this side. And you might have to use law of sines or law of cosines to find what you actually need before you can perform this. But the area is simply equal to half times leg times the sine of the angle between. You're just plugging it in and clean it up. That's all you're doing. So that'd be sine of 30. Since we know that when you don't have to use your calculator, sine of 30 is a half, so this is a half times 6 times 7 times a half, which is, I think, 10.5 units squared. Again, you just simply plug it in and evaluate it. Okay, like I said, on some of these, you don't have the information you need. The area of this is 1/2 times 5 times 8 times the sine of this angle. And we have no idea what this angle is equal to. So what you're going to have to do is either use your law of sines, law of cosines, these other methods that we talked about yesterday, and hopefully this will be a little bit of a review for you too. How do I find the missing side lengths or missing angles? This is your law of sines and your law of cosines. Let's do this. I know that the sine of 40 from the law of sines, the sine of 40 over 8 is equal to the sine of this angle, and we'll call it y. Sine of y over 5. So we can use this information to actually find out the missing pieces. From the law of sines, we multiply these two, divide by 8, and that tells us what the sine of y is equal to. Again, it's 5 times sine of 40 divided by 8. 0.4017, and then we do inverse sine of that, second sine of that answer, and that gives me that y is about a 23-degree angle, or actually it's 23.6, so it's closer to a 24-degree angle. Also a reminder from yesterday that that's not the only answer, that you could also have a possible and let me show you, on some of the problems last night, it would ask you, let me write that a little bit cleaner, 24 degrees. On some of the problems yesterday, it would ask you how many possible triangles there are. Well, from the inverse sine, that's not the only answer. Y could also be a second quadrant angle. Here's 24. You have a second quadrant angle that has that same reference angle, which would be 156 degrees. But I want to show you something. Y could be 24. We're okay with that. Y cannot be 156. Because if this is 156 degrees and this is 40 degrees, you're already well over that 180 degrees of a triangle. So we can actually throw that one out. So Y is 24 degrees. This angle was 40. 40 and 24 gives you 64, which means that this angle would be 116 degrees. Does everybody understand follow how I got that? The three angles have to add up to 180. So 40 and 24, 64. Subtract that from 180, leaves you with 116. And the whole purpose of that was now we can find the area. Now we can do area is equal to 1/2 times leg times the sine of the angle in between. So this, again, this formula is used anytime that you're looking for the area and you're given two leg lengths and the angle between the two. I'm not going to plug this in, but you can do it. My suggestion is, as I'm plugging this in, I don't know. Me personally, I just like cleaning it up. I'll go ahead and do 1/2 of 8 is 4. 4 times 5 is 20, and I'll just type in 20 times the sine of 116, and then that'll give you the area for this triangle. Okay, last method of finding the area of a triangle is again called Heron's formula. Heron's formula is used when you have three leg lengths. You could have actually, after that first, you could have done law of sines, cosines, whatever, and found this third leg length, and you could have found this area by using Heron's formula as well. Heron's formula is very easy to use. Step 1, find your semi-perimeter. Semi meaning half. All we're going to do is find the perimeter of this triangle, which is 17, and take half of it. That's your semi-perimeter. And Heron's formula says that the area is equal to the square root of S times S minus, and it doesn't matter which one's A, B, and C. We'll let this be A. So the square root of S times S minus A, which would be 2.5, times S minus B, which would be 1.5, times S minus C, which would be 4.5. Multiply these together, take the square root, and you're done. I get somewhere around 11.98. So again, just to use Heron's formula, find the semi-perimeter, because the actual formula is S times S minus A times S minus B times S minus C, where A, B, and C are the three leg lengths, and S is the semi-perimeter. So our semi-perimeter was 8.5, and then subtract 8.5 minus your three leg lengths. Take the square root of it, square root of the product, and you're finished.